Hello class, this is Math 1440, section 9.1. Let's go over this problem. Verify that y is equal to e to the negative x plus x minus 1 is a solution of the differential equation y prime plus y equals x. So a differential equation is an equation with a derivative. It can be y prime, it can be y double prime, any derivative at all. So a derivative of any order. So here's what we're asked to do. We want to show that this value of y solves this differential equation. So they're giving us the solution of right here. They're telling us that this is the solution. All we want to do is verify that yes, indeed, when y equals this expression, it does solve this differential equation. So the first step, because I see a y prime, is to find y prime given our y. So here we go for the solution. First, we need to find y prime because that is in our differential equation. So how do I find y prime? Well, we know that this is our value of y right here. So just go derivative plus derivative minus derivative. So what's the derivative of e to the negative x? Is going to be e to the negative x, and then by the chain rule times negative 1, plus, and then the derivative of x is 1, minus the derivative of any number or constant is 0. So that's what I have here. Y prime is equal to e to the negative x times negative 1 plus 1. We don't have to write plus 0. And then simplifying, I get my y prime, which is the same thing as saying the derivative of y, is simply negative e to the negative x plus 1. Okay, so now that I have y prime, next, let's verify that this value of y, which they gave us, thank you very much. Next section, we're going to have to earn it more. We're going to have to actually find y to solve the differential equation. But we're just starting off with differential equations, which is chapter 9. So we're starting off gently. So this is the y they gave us. So let me get backtracking a little bit here. Next, we want to verify that this value of y does indeed solve the differential equation. And the differential equation was given as y prime plus y equals x. So to see that this value of y does solve this differential equation, when I see y, I'm going to replace it with what they gave it to us as. When I see y prime, I'm going to write what we just found y prime to be. And then we want to, and the best way to verify that this value of y solves this equation is to just work with the more complicated side of the differential equation, which is the left-hand side, LHS, left-hand side. So I'm just going to start with the left-hand side. I'm not going to assume that this value of y solves the equation, this differential equation. You don't want to assume what you're trying to verify or prove. So I'm going to start with the left-hand side and then make my substitutions and then do some fancy footwork, not too fancy. And then ultimately I want to show that we do indeed get x, which is the right-hand side. So if I can show the left-hand side equals the right-hand side without assuming it, then we are done. Okay, so let's look at the left-hand side, LHS, of the DE, differential equation. So this is the left-hand side of the differential equation, just y prime plus y. So just focusing on that, the left-hand side is y prime plus y. We just found y prime to be negative e to the negative x plus 1. So these two terms is y prime by substitution, plus, and then for y, I'm going to write what they gave us y to be. So plus, this is the plus, and then by substitution, instead of writing y, I'm going to write e to the negative x plus x minus 1, because that's what y was given as in our problem. And we did that by substitution. And now look at this. Doesn't the minus e to the negative x cancel with this positive e to the negative x? And doesn't the plus 1 here cancel with this minus 1? So the only thing I'm left with is x. So this just equals x, which is what I wanted, because that is the right-hand side. So Dropping back, we've just shown the left-hand side does equal the right-hand side. So therefore, the value of y they gave us is indeed correct. It is a solution to the differential equation. And we are done. Let me back off a little bit here so you can see the whole thing. The whole... Okay, so there's the whole problem. You can click pause if you want. Okay, so that's all. Have a good day, everyone. Bye-bye.